Okay, we have 6.3 part 1, adding and subtracting expressions today. We need to be able to find the LCD, and once we find the LCD, we'll move on to the adding subtracting part. So adding subtracting rational expressions is very similar to adding and subtracting the fractions that we're normally used to doing for middle school. So the first thing that we have to do in order to add and subtract these fractions, this 1/2 and 2/5 example, we would have to find what your lowest common denominator is. That stands for LCD. In order to find that, you just got to find the multiples of 2 and the multiples of 5 that would meet up. So 2 times 1, 2 times 2, 2 times 3, times 4 times 5, 5 times 1, times 2, times 3, times 4, times 5. It looks like 10 is the first number that they both have in common. So that's going to be the first, or your lowest common denominator. There might be more, like the number 20 or 30, but the L stands for lowest. So we're trying to find the lowest common denominator. So we got to make the bottoms be 10. In order for the left bottom to be 10, you got to multiply by 5. The right bottom's going to multiply by 2. So now I'm left with 5/10 plus 2/10. And if you recall from doing this a couple of years ago, you add the tops, but you keep the bottom the same. So it'd be 7/10. Then from here, if we take a look at the final answer, you always try to simplify it if you can. So if I got like 8/10, I can simplify that down to 4/5. The next one, 8 and 12, if we do my multiples out, 8, 16, 24, 32, 40, 8, 12, 24, 36, 48, 60. So it looks like 24 is our lowest common denominator. So we want to get the bottoms, the denominators, to be 24. So the bottom left, we'd multiply by 3. The bottom right, we'd multiply by 2. And if we do that, you get whatever you multiply in the bottom, you have to multiply in the top. So now we're left with 9/24 plus 10/24. And you can add the tops together, and that would give you 19/24 in the end. We look to see if there's a number that can divide into both, and there's not. So that would be your final answer. So that's just a review of what you know at this point. Now we're going to possibly get into some pieces that you might not know. The first piece is just finding the LCD. So this first example is an easy one because it's only numbers. So we do the same thing that we just did. Multiply out 2, 3, and 4 and see what number it hits first. So 2 times 1, 2 times 2, 2 times 3, 2 times 4, 2 times 5, 2 times 6, 3 times 1, 2, 3, 4, 5, 6. And then 4 times 1, 4 times 2, 4 times 3, 4 times 4, 4 times 5, 4 times 6. So then we look for the smallest number they all have in common. Sometimes you might have to go beyond 6. It's not often, but sometimes you do. 12 would be my LCD. So that's what they're looking for in this little section. The next one has numbers and variables. So we'll do the numbers first, separate from the variables, because the variables is always the easy part. 3, 6, 9, we got 3, 6, 9, 12, 15, 18. We got 6, 12, 18, 24, 30, 36, 9, 18, 27, 36, 45, 54. So the first number they all have in common is an 18. So that would be my lowest common denominator as far as the number goes. And then for these variables, if it's a monomial, which means a single term without any plus or minus, you just always represent the biggest number of x's that you see. So it'd be x squared there. That's all you got to do to find the LCD for number 2. Number 3, if we just did the numbers, if we multiply them out, 15, 20, 25, 30, 6, 12, 18, 24, 30, 36. It looks like 30 is my winner for my number. And then the biggest number of x's I see is an x to the third. So that'd be my LCD. So that is all my monomial pieces. So those are the single terms. The next row has binomials. They're a little bit tougher sometimes. But if you just see two different binomials, what's nice about that is that all you have to do is represent each binomial you see, and that's it. So it'd be x plus 1 and x minus 6. And that'd be your LCD. Same with the next one. It's a little bit easy because there's no factoring involved. That'd be x plus 12 and x plus 1 would be your LCD. So that's your lowest common denominator. So you just got to represent each binomial you see one time. Now 3 is a little bit tougher because we have some factoring to do. Bottom left, if we were to factor it, we get x plus 2, x minus 2. I didn't mean to, where's my eraser up here? Sorry. That one. X plus 2, x minus 2, not 4. I just was looking at the 4. So then each binomial I see at the bottom is an x plus 2 from the far left, and then I see the x minus 2 twice, and you only got to write it one time. That's all we got for the LCD for that one. So that covers the first half of what we have to do for our homework. Once you understand finding the lowest common denominator, now we're going to actually be doing the steps that we did up above with the fractions with only the numbers. But now we're going to do it with some variables. This first example is easy because the bottom's already the same. So I see that my LCD right away is 6x. So I don't have any math to do to be able to get the bottoms to be the same, because that's always the goal, is making sure that the bottoms are the same. So if we look at these steps up above, here are your steps if you want to take a look at them. Since the bottom's are already exactly the same, we just add the tops. So if you add 2x and 8x, you get 10x. If you add 5 plus 9, you get 14. The bottom has a 6x. And then just like any other fraction, if we can simplify, we do. So we're going to try. So that means we're going to try to factor the top a little bit. If we factor the top, I think we could pull out a greatest common factor of a 2. And because 2 divides by 6 over here, because they're both monomials, we learned earlier in this chapter that we can divide those and then be 1/3. So it's going to be a 1 and then a 5x plus 7 over a 3x. We can't cancel anything else because that's a binomial over a monomial. We can only cancel the single terms that are by themselves. So that's an easy one because the bottoms are already exactly the same. Number 2 is a little bit more difficult because we have to actually find the LCD first. The multiples of 2 and 3, I think we're going to hit the number 6 first. So that'd be my LCD. So the same steps that we did up above with the fractions without any variables is what we're going to do here, where we multiply each of the fractions by the number that would get it to be that LCD. So the bottom left is a 3, so we're going to multiply by 2 on the top and bottom. The bottom right is a 2, so we're going to multiply by 3 on the top and the bottom. So when we do that, it looks like this up top. 2 parentheses 3x minus 7. There's a minus sign in between them. We have a 3 that we're multiplying by, and that's 10x plus 3. So if we multiply this out, this is 6x minus 14. This is 30x minus 9. And we're left with negative 24x minus 23 all over my LCD of 6. We always try to simplify if we can. I believe the only thing we can actually do, though, is pull out a negative 1. 24x plus 23. So that doesn't change anything. So that would be my answer. If you showed this answer in the show your work portion, that would also work out. So both of them are good since there's nothing that actually canceled. Number 3 gets a little bit tougher because now we have these binomials on the bottom. So if we were to factor this first to find out what my LCD is, I have x plus 5, x minus 5. This side, I have x minus 5, x minus 1. So then from here, I can look at the bottoms, and I see that my LCD, if I represent each binomial one time, would be x plus 5, x minus 5 I see twice, but I'm only going to write it once, and an x minus 1. So if I'm looking at the bottom left, the only thing that's missing from my LCD is an x minus 1, so that's what I'm going to multiply by the top and the bottom. On the right side, the only thing that's missing is an x plus 5, so that's what I'm going to write on the top and the bottom. And now I'm just going to take care of the top. So if I just take care of the top here, I get a negative 2 times an x minus 1 plus an x times an x plus 5. And that would be negative 2x plus 2 plus x squared plus 5x. And if I combine like terms, I get x squared plus 3x plus 2 over my LCD, because the bottoms are the same, so I could put them all together as one fraction. And I always try to simplify if I can. Are there any multiples of 2 that add to give me 3? I think it's 2 and 1. Both positive, though. So I don't see anything that's going to cancel, unfortunately. Man, that would have been nice. So I'd accept this one or this one. They're both good since nothing canceled. If something canceled, then you got to cancel them. So that's number 3. The next one, number 4, if we factor our LCD, then in this case is going to be the binomials I see on the bottom. That's plus 2 plus 1. I see plus 2 twice, but you only got to write it once. So that means the only thing that we're missing is the x plus 1 on the bottom right. So that's what I'm going to multiply by the top and bottom. Now the bottoms are the same, and you can add the two fractions together. Before we add them together, let's do all of our multiplying up top. So we have 1 minus 2x plus 5x plus 5. All I did was distribute this 5 into the parenthesis right there and right there. And then we would get 3x plus 6 over my LCD of x plus 2, x plus 1. So if I pull out a GCF, I get a 3 on the outside, x plus 2. Ooh, I see some that cancels. This is nice. I like these ones. The x plus 2s are gonzo. So then in the end, we get a 3 on top and an x plus 1 on the bottom. So that'd be the answer for number 4. Okay, that's not so bad. Ooh, I like 5. 5 is nice because the bottom's already the same. So that means that all we have to do is distribute that negative into the top right. So if we distribute this negative 1 into all 3 of these, then we would get x squared plus x plus 22 minus 2x squared plus 3x minus 10. So all I did was change all the signs. So we would get negative x squared plus 4x plus 12. That's over this 3x squared plus 9x plus 6. So now it's one fraction. Once we have it down to one fraction, just like we did on the first couple days, we try to simplify that fraction down. So can we is the question. If I pull out a negative 1 up top, I get x squared minus 4x minus 12. And I don't believe, oh no, there is. We can factor that. I think that's 6, negative 6 and positive 2. On the bottom, I see a GCF of a 3. 3x plus 2. So can I factor that? I think I can. So it's x plus 2, x plus 1. So the x plus 2's cancel. I'm left with negative 1, x minus 6, and a 3, and an x plus 1. So that would be my answer for that one. And I think that's probably enough of seeing these. There's a few more left that you can practice, and then your teacher can show you what those answers are too. Have a great day. I'll see you guys next time.